property of addition. When you multiply numbers, the order will not change the result.
Go ahead and pause here for a second, and you should write this down. The commutative property of multiplication says that for any numbers, A times B, it's the same thing as B times A. That just means that you can write any numbers and change the order, and it will not change the result. It's the very same thing as addition. Okay, once you've written that down, go ahead and press play.
Excuse me, Mr. Two? Is there some sort of easy way that I can figure how many pictures can be displayed on 25 screens? And each shows 3 rows with 4 photos in each row?
How were you going to calculate the number of pictures, Eddie?
I was going to multiply 25 times the quantity 3 times 4. But there must be an easier way.
I think I see a way. Use the commutative property of multiplication to write 3 times 4 as 4 times 3. Then... Mr. Two, is there an associative property for multiplication?
Yes, there is. The way factors are grouped does not change the product.
So I can multiply 25 times 4 first. That's 100. And 100 times 3 equals 300.
Let's see if we get the same product when we multiply 25 times the quantity 4 times 3 on the calculator.
4 times 3 equals 12. And 25 times 12 is 300.
So, the way 25, 4, and 3 were grouped does not change the product. This is an example of the associative property of multiplication. The way the factors are grouped does not change the product.
Okay, this is another important thing that you should write down, the associative property of multiplication. It's very much the same as the associative property of addition, but it's just for multiplication. You can change the way anything is ordered or grouped, and it will not change the product. It's just like the associative property of addition. It's like if A and B and C were all partners on a project, but A and B were sitting together and C was sitting in another group. They still are all working on the project together. The next day, maybe A sits in the other group and B and C sit together. They're still all working on the same project, but they're just in a different order or different seating arrangement. That's what the associative property means. Once you've written this down, go ahead and come back and press play.
Mr. Two, I know the identity property of multiplication.
Well, then please share it with us.
The product of 1 and any number is that number. For example, 5 times 1 equals 5, and 1 times 3 equals 3.
Outstanding!
Okay, this is the third property of multiplication that you should write down. It's the identity property of multiplication. And the identity property of multiplication says the product of 1 and any number is the same number. It's just like the identity property of addition, except instead of 0 added to any number equals the same number, this time it's 1 times any number equals the number. So 1, we also can call that the multiplicative identity. Okay, and I'll write that down when we take our notes. Go ahead and press play once you finish writing that.
Another property is the multiplicative property of 0.
Zio has a property named after him?
No. I said the multiplicative property of 0. The product of 0 and any number is 0.
Ha! I always thought Zio was a 0.
Hey! For example, 7 times 0 equals 0, and 0 times 9 equals 0. Any number times 0 equals 0.
Okay, that's another property that you should write down is the multiplicative property of 0, and that just says that 0 times any number is 0.
In problem 6 of your lesson notes, what property is shown?
Okay, hopefully you can look at this and see 12 times 35 equals 35 times 12. Go ahead and write this example down in your notes, and then Come back and see if you guessed right. Hopefully, you will have said that this is the commutative property of multiplication.
If you multiply in different orders, you get the same result. That's the commutative property of multiplication.
Yes. In problem 7 of your lesson notes, name the property shown.
Okay, go ahead and in your notes, write down the example 6 times 0 equals 0 and write down the property that you think this is. Come back as soon as you think you know.
If you multiply any number by 0, the product is 0. That's the multiplicative property of 0.
6 times nothing is nothing. Makes sense.
Nice work. In problem 8 of your lesson notes, what is this property?
Okay, go ahead and look at this problem and write it down in your notes. 7 times 6 times 5 equals the quantity 6 times 5 times 7. Look at it carefully and see if you can figure out what this is.
The order of the factors is switched. That's the commutative property of multiplication.
Well done.
Okay, how many of you thought that was associative just because it had parentheses? That's a common mistake that a lot of people make. But really, this is the commutative property because the 6 times 5 moved in front of the 7. But the numbers inside the parentheses, 6 times 5, stayed the same. So that's why it's the commutative property of multiplication.
In problem 9 of your lesson notes, name the property shown.
Okay, go ahead and write this example down. 3 times the quantity, 2 times 8, equals the quantity of 3 times 2 times 8. Come back when you think you know the answer. Press pause now. Hopefully, you have said,
The products are equal even though the factors are grouped differently. That's the associative property of multiplication.
Very good. What property is shown in problem 10 of your lesson notes?
okay, go ahead and write this down. In your notes, 7 times 1 equals 7. Hopefully you know this pretty easily, and then come back and press play once you think you have the answer.
If you multiply any number by 1, the product is that number. That's the identity property of multiplication.
A fine job.
Let's use these
Okay, we're actually going to stop here for a second, and now I'm going to go into GoodNotes and make sure you have all of these properties written down, and then we will learn one last property, the distributive property. Go ahead and go to your GoodNotes, and let's write down the commutative property of multiplication. Hopefully you already have it, but I'll go ahead and write it as well. This just says A times B equals B times A. Okay, that means you can change the order and not change the product. Change the order of the factors and not change the product. Hopefully you have written some examples as well from the video. Okay, go ahead and go to your next page. Okay, the next one is the associative property of multiplication. Very same as the associative property of addition, except with multiplication. This just says that A times the quantity of B times C equals the quantity of A times B times C. You can change the grouping. Change the grouping. Remember, associate means group. Okay, I'm going to actually write that up here. Group. Groups. Change the groupings of the factors without changing the product. Without changing the product. Okay, and go ahead and go to your next page. The multiplicative identity property. First of all, let's write down the multiplicative identity, because sometimes you will hear it phrased that way. If someone says, what is the multiplicative identity? That means the number 1. It is the multiplicative identity, and all it means is A times 1 equals A for any number. Any number times 1. Any number times 1 equals the same number. That's why it's called the multiplicative identity. Okay, now the multiplicative property of 0. That is, this property says that A, for any number, A could be any number, A times 0 equals 0. Okay, so any number in the whole world, any number times 0 equals 0. Always true. Okay? And your very last property is going to be the distributive property of multiplication over addition and subtraction. We're going to go back to the robots and learn a little bit about this before we write it down. Okay?
Oh boy, this looks good. A free month of pizza to whoever eats the most slices during lunchtime.
I think we've got a chance. I don't think we're in sight.
Good. Let's win some eating. 10 slices, my good man, and don't spare the anchovies.
Sure, I'll give you 10 slices. As for myself, I'm having 10 pies.
Eddie!
The early bird gets the pizza pie, my friend.
You know, Eddie, you can stop now. We gave up 20 minutes ago.
Oh, no more. Oh, I ate enough to last me a Plutonian year.
The winner of this contest gets the exact amount of slices he ate today, delivered to class every day. I wonder how many slices that is in a month.
That depends on the number of days in the month.
Let's say the month has 31 days. What do? Multiply 31 times 395?
That's how you do it.
Well, I guess I'll never find out then. 31 times 395. Oh, that's too hard.
That multiplication isn't hard if you distribute the numbers wisely.
What are you talking about?
Using the distributive property, Eddie. Multiplying is not hard if you distribute your numbers wisely. We can show the product of 4 times 7 with the area of a 4 by 7 rectangle.
Mr. 2, why do we have to solve problems this way? I already know the answer to 4 times 7. It's 28.
That's a good question, Trillion. Because you already know the answer, you'll be able to understand the distributive property model better. Then you can use it to solve more difficult problems. 4 times 7 equals 28. Now watch as I solve 4 times 7 in another way. I rewrite the factor 7 as a sum, 5 plus 2. Now we split the 4 by 7 rectangle into a 4 by 5 rectangle and a 4 by 2 rectangle. We can rewrite 4 times the sum of 5 and 2 as 4 times 5 plus 4 times 2. Now we're ready to solve the partial products. 4 times 5 is 20, and 4 times 2 is 8. 20 plus 8 is 28. So, 4 times 7 is 28, and 4 times the quantity 5 plus 2 is 28. And 4 times 5 plus 4 times 2 equals 28.
Does this show a property of addition?
It looks more like a property of multiplication to me.
Actually, I've just shown a model of the distributive property of multiplication over addition. It means that multiplying a number and a sum is the same as multiplying the number by each part of the sum and then adding.
Okay, this is super important. I want you to write this down, what the distributive property really means. It really means that multiplying a number and a sum, which is the 5 plus 2, it's the same as multiplying the number by each part of the sum and then adding it together, adding the two products together. Once you've written that down, come back and press play.
Let's try another problem. Model and solve 2 times 7 by rewriting 2 times 7 as 2 times the quantity 4 plus 3.
Let me try. We need to start with a 2 by 7 rectangle. We need to split the rectangle into a 2 by 4 rectangle and a 2 by 3 rectangle. If you distribute 2 over the quantity 4 plus 3, you get 2 times 4 plus 2 times 3. Now we need to solve the partial products and then add. 2 times 4 is 8. And 2 times 3 is 6. Add 8 and 6. That's 14. You got it.
Okay, I know that you're probably thinking, why do we have to look at these models? This is so easy. This math is so easy. Why do we have to do this? This is just showing you what the distributive property really means. And models can really help you visualize what is happening with the numbers.
In problem 1 of your lesson notes, solve 6 times 5 by renaming 5 as the sum of 3 and 2.
Okay, so I want you to think about how you would write this down if you were using the distributive property that we just talked about. See if you can try this in your notebook and see what you come up with. You want to think about 6 being distributed over 3 and 2. Come back as soon as you think you're ready and press play.
I need to distribute 6 over the quantity 3 plus 2. When I distribute, I get 6 times 3 plus 6 times 2. Now I need to multiply. 6 times 3 is 18, and 6 times 2 is 12. 18 plus 12 is 30. That means 6 times 5 equals 30. And 6 times the quantity 3 plus 2 equals 30.
You're right.
In problem 2...
I'm actually going to skip that and go right into the next set of notes.
Let's look at another model of the distributive property of multiplication over addition. 2 times 14 is the same as 2 times the sum of 10 and 4. When you distribute, you get 2 times 10 plus 2 times 4. 2 times 10 is 20, and 2 times 4 is 8. 20 plus 8 is 28.
In problem 3 of your lesson notes, model 4 times 12 by renaming 12 as 10 plus 2.
So go ahead and rewrite that using the distributive property like they just did in the examples. Okay, press pause and write it down in your notes and then come back and check. Okay.
4 times 12 is equal to 4 times 10 plus 4 times 2. 4 times 10 is 40, and 4 times 2 is 8. 40 plus 8 is 48.
Okay, hopefully you're really starting to see how this is working. And don't worry, I'm going to write it down and write a few more examples for you.
In problem 4 of your lesson,
Let's go ahead and skip that for a second and let's just go to, let's see how modeling will work in one other way.
let's use the distributive property of multiplication over addition to multiply 12 times 14.
So, do we just use the distributive property?
To multiply these numbers, Eddie, it requires using the distributive property twice. We start by rewriting the factor 12 as 10 plus 2 and the factor 14 as 10 plus 4. Let's see what it looks like as a model. Now I distribute each part of the sum of the first factor over each part of the sum of the second factor. That is, I multiply 10 times the quantity 10 plus 4, and I multiply 2 times the quantity 10 plus 4.
Okay, this one seems pretty complicated, doesn't it? The original problem, if you remember, was 12 times 14, and that's something that most of us don't know in our head. So the distributive property will help us solve it. So watch how they solve it.
10 times 10 plus 10 times 4 plus 2 times 10 plus 2 times 4. Now let's simplify the partial products. 10 times 10 is 100. 10 times 4 is 40. 2 times 10 is 20. And 2 times 4 is 8. And 100 plus 40 plus 20 plus 8 is 168. So the product of 12 times 14 is 168.
Okay. Hopefully you can see how they broke that down. All right, let's go ahead and jump right to subtraction. I want to show you one example with subtraction, and then we will write this down.
Don't tell me. There's a distributive property of multiplication over subtraction.
Indeed there is. Multiplying a number and a difference is the same as multiplying the number by each part of the difference and then subtracting.
Huh? I don't get it.
What?
Maybe an equation will help. Multiplying a number and a difference is the same as multiplying the number by each part of the difference and then subtracting.
I think I get it, but I'm not sure.
Okay, go ahead and write this down. This is the last part that we're learning today, and that's the distributive property of multiplication over subtraction. And basically it just means that distributive property works with multiplication and addition or multiplication and subtraction. And it's just saying that you can take a number and multiply it times a difference, which is the 5 minus 2 part, and it's the same as multiplying the number by each part of the difference and then subtracting. Okay, go ahead now and watch.
Maybe I can help with an example. Let's use the distributive property of multiplication over subtraction to multiply 6 times 19. Who can tell me how to write 19 as a difference of two numbers?
How about 20 minus 1?
Excellent choice. Now, Luria, how would you rewrite 6 times the quantity 20 minus 1 using the distributive property?
I'm going to pause here for 1 second and just say to you, you're probably thinking, why do I have to do this? The reason you might do this is, let's say that you don't know 6 times 19 in your head and you don't feel like multiplying it out long way, and you don't have a calculator or you're not allowed to use one. This is a way that will simplify the process for you.
Distribute 6 over 20 minus 1. That is 6 times 20 minus 6 times 1, which is 120 minus 6. And 120 minus 6 equals 114. Hey, I see why 20 minus 1 was an excellent choice. It's easier to multiply 6 times 20 and 6 times 1 and subtract than it is to multiply 6 times 19.
That's right, Luria. Multiplication is easier if you distribute your numbers wisely.
This distributive property is too cool.
Okay, hopefully you think so too.
How can we use the distributive property to multiply 15 by 38?
Okay, let's stop there actually, and let's go back to your good notes, and let's go ahead and write out the distributive property in a way that you can remember it. Okay, so first of all, you know that the distributive property works for multiplication over addition and subtraction. Okay, and what it says is, let's pretend if we have letters, okay, variables. A times the actually, I'm going to erase that. I'm going to write this with parentheses. You know if you have a variable next to parentheses with no sign in between, that means to multiply. A times B plus C equals A times B plus A times C. Let's try it with a few numbers, just so you know what I'm talking about. 3 times the quantity of 4 plus 5 is the same thing as saying 3 times 4 plus 3 times 5. I like to put parentheses around these to keep it neat, and here's how it works. 3 times 4 is 12, 3 times 5 is 15, 12 plus 15 is 27. Let's see if that's true. 4 plus 5 is 9, and 3 times 9 is 27. So that worked. Okay, let me show you one more example. Go ahead and add another page. Okay, and let me show you.